Hey class, welcome back to chapter 3, linear relations and equations. Today we'll be solving linear equations with one unknown in exercise 3C. So to solve an equation with only one variable, we need to rearrange the equation to get the variable alone on one side of the equal sign. We will use inverse operations to do this. Now, when we substitute, we use BODMAS or BIDMAS. When we rearrange, we use SADMOB, so swap it. The inverse of BODMAS is SADMOB, and there is a SADMOB on the screen to remind you of that, okay? So, I've got two examples for you today. The first, it's an annoying one, but we'll make it do. All right, the first thing that we need to do is the last thing we would do if we were to use BODMAS. So we're looking for additions or subtractions. We have a plus 9 here, so I'm going to get rid of that by subtracting 9. The opposite of plus 9 is to subtract 9. You can write your working out like this if you'd like. There are a number of ways you can show your working. You could skip this green part entirely. So 3 bracket 2 minus x is left over 4. And we have 15 minus 9 is, of course, 6. The next thing we need to do to get x on its own, so we would usually go 3 bracket, so we would do the brackets first, then the multiplication. So we're actually going to reverse the division. To do that, we're going to go 4 times. They're now gone, and 6 times 4. We get 3 bracket 2 minus x equals, and as we go through, you'll notice that the left-hand side gets more and more reduced until we have only x left. 6 times 4 is, of course, 24. We then need to get rid of this times 3 out the front. So to do that, I'm going to divide both sides by 3. That cancels out that. We have 2 minus x equals 24 divided by 3 is 8. All right. Next, we have a positive 2 here. So to get rid of that, we're going to subtract 2. They are now gone. 8 minus 2 is 6, but we have negative x here. To make that a positive, we need to make that a negative. So we effectively multiply both sides by -1 to do that. I'm just running out of room on my screen. Okay, so x equals -6. All right, we'll try another example, a little bit of a trickier one this time. Actually, a lot of a trickier one this time. All right, what you'll notice here is that we have some denominators and they're both different in our fractions. So if we were to add or subtract fractions as we would in year 7, we would make the denominators the same, and we are adding two fractions here. So to do that, we're going to use cross multiplication. The denominator here is 3, so I'm going to multiply the top and the bottom here, or the whole fraction, by 3. Okay, whatever I do the top, I need to do the bottom. Same thing over here. The denominator in the first fraction was 5, so I'm going to multiply the top and the bottom by 5. All right. This is going to give us equivalent fractions of, and I'm going to keep some things in brackets for the moment. We'll expand those when we're ready. And both denominators now are 15. And that still equals 1. Now, to get rid of that denominator of 15 on both sides, we're going to multiply the whole lot by 15, both sides. Whatever we do to one side, we must do to the other. You're going to hear that a lot this chapter. So now, keep my green on for a second. Those are gone, and so is that one, okay, because all of it's multiplied by 15. And we end up with 3 bracket 2x minus 3, close brackets, plus 5, x plus 7 equals 1 times 15 is, of course, 15. Now we're going to make our lives a little bit easier. And we're going to expand those brackets. Okay, both brackets. There's a lot of algebra at this step. You probably won't need to do anything this big in the exercise, but that's okay. I'm setting you up for later exercises. So 3 times 2x, and we have done this so many times before. You did expansion of brackets in year 8. We get 6x minus 3 times 3 is 9x. Oh, sorry, just 9. Don't write 9x. Plus, because now we're in the middle, 5 times x is 5x. And 5 times 7, both are positive, we get 35. And that equals 15. Okay. We're going to now combine our like terms. So again, we are reviewing things from year 8, 9, and 10. 6x plus 5x is 11x, and negative 9 plus 35 outside of those boxes is 26. Positive 26. And equals 15. And now we have an equation that is much easier to work with. So we're going to subtract 26 from both sides. They're gone. All right. And that leaves us with 11x over here equals negative 11 here. And then I have run out of room on my screen, but that's okay. We're going to divide both sides by 11 to give us our answer of x equals negative 1. All right, that is a very long and complicated example. I have covered basically every single step that you might possibly need in this chapter, plus some. All right, if you have brackets, expand them first, group your like terms, and then work your way back. If you have fractions, make your denominators the same, work your way out, okay? This is all stuff that you have done before. Finally, you can use, and I would urge you to check all your answers using the solve function on your CAS, and because I've written over it, you cannot even see that. But it says note, you can also use the solve function on your CAS. So what we could have done was solve, open bracket, I'll write it all in a few, let's go red. We could have written solve, open bracket, all of this, just as it was written in black originally, comma x in there before we close the brackets, okay? And that would be how you'd complete that calculation on your CAS. But as always, guys, good luck with the work. Let me know if you have any questions, and I will speak to you all very soon.